I know exactly what you're thinking. You're thinking, James, tell me exactly what happens if I am up a well big hill. And here is my well big hill. Here it is. It's a bit of a volcano. There it is. Volcano at the top. Doesn't look like a hill, does it? But there's a bit at the bottom like that. And I've got a snow peak on here. Look at that. It's all snowy at the top. There's my mountain. I know you're thinking, God, James, you can draw. Now, I'm going to imagine that you are above this line here. Okay, and this line, just for the sake of now, I'm going to say it's 2,400 metres of altitude up in the air. That's about 8,000 feet, for those of you that prefer imperial. So we're above 2,400 metres. That's sort of like some of the bigger mountains in Europe, for example, the Alps, a couple of the Pyrenees. I'll come back to that point in a second. But what I'm going to do here is, what is the impact of altitude? Now, first of all, we're going to talk about high altitude, but later on we're going to talk about this little fella down here who's at low altitude. So we've got low altitude to consider as well. But what I'm going to do is I'm going to look at high altitude and I'm going to look at the acute effect. Remember that acute means the immediate short term. Well, this is what happens if we go to if this fella goes up this mountain like this is what's going to happen. They are going to experience a down arrow, a reduced rate. So this is a slower rate of oxygen and CO2 diffusion. So think about it as your gaseous exchange, your gaseous exchange. That is going to happen more slowly. Why? Because the density or the availability of oxygen in the air at that altitude is less. Therefore, we're going to actually exchange less of that mixture, that particular gas from that mixture of gases. Now, furthermore, we are therefore going to experience a decrease in hemoglobin HB saturation. Now, generally, at sea level, this person's going to have in the region of 100% oxyhemoglobin saturation or hemoglobin saturation. Okay, so it's pretty high. When we go to altitude, that can decrease, and if it decreases severely, we can experience what's called hypoxia or altitude sickness. Also, because of this, we experience a decreased delivery. We get less oxygen to mitochondria. So remind yourselves that mitochondria are organelles within cells which are the sites of aerobic respiration. They are the energy factories of each cell. And if less oxygen is getting to them, therefore we can do less respiration aerobically. Therefore, we get a down arrow, we get a decreased in aerobic energy release. That will mean that we reach things like fatigue sooner, for example. So we could say we reach obla early. Now I'm going to stress what I mean by the word early here. When we say the word early, we reach onset of blood lactate accumulation, fatigue. If we reach that early, it doesn't mean sooner, it means a lower intensity. So I would have to work, this person, if they went up, this person would have to work less hard to reach that sort of exhaustion, that inflection point, depending on if you've done that tutorial yet. Now, what about low altitude? What's the impact of this? Well, it's kind of the opposite of all that. But as a result of that, there's no specific acute impact. We kind of function as you do. So nothing really from that perspective, but this is where life's about to get interesting. We are now going to talk about the chronic impact, the long-term, the adaptive impact. What if you go to Fon Romeo, the Team GB high altitude training camp in the Pyrenees between France and Spain, and train there for 6 weeks? What if you live at high altitude in wherever it is you live in the world? What if you don't? That's going to obviously be over here at the low altitude. What are the impacts of this? Well, first of all, let's go to our big list, which is going to be over here. I'm going to give you lots and lots and lots of positives, lots of positives. First of all, positive, we get up arrow, heart strength goes up, strength of heart. The heart becomes stronger, thicker, engorged. It becomes hypertrophied. As a result of that, we get up arrow, more stroke volume. As a result of that, another positive, we get decreased resting heart rate. So because our stroke volume goes up, we can do fewer beats per minute at rest. As a result of that, we have got an increased exercise heart rate range. Think about it. If your resting heart rate goes from 80 beats per minute down to 60 beats per minute and your maximum heart rate is 200, you've now got a range of 140 beats per minute for exercise conditions as opposed to 120 before that training, right? Or that altitude development. So really, really useful. We also get an up arrow, an increase in blood plasma. Fantastic. That's of course useful for suspending more red blood cells. We therefore get more red blood cells, more RBCs. They carry oxygen, as you know. As a result of that, we get an increase in O2 carriage. Can you start to see how positive from an athletic perspective, from a movement, exercise, health perspective, altitude and altitude training can actually be. Now, of course, when you first get up there, it can be pretty damaging. Don't go and try and run a marathon up a high Himalaya. You're gonna struggle, okay, and possibly die. But when done correctly, this can have a really, really big impact on people. We also have a positive. We have better waste removal. Of course, we're removing things like lactic acid, which is converted into other products and breathed out. We can breathe out more carbon dioxide as a result. Therefore, we also get up arrow better nutrient transport. Think about amino acids, think about glucose, think about lipids. We can transport those better. We get an up arrow, an increased strength in smooth muscle. Numerous times recently, I've been teaching on this course about vasoconstriction and dilation. That's done by smooth muscles. They become stronger, and we get capillarization at the alveoli and the muscle. Now, I'm going to pause there because I just want to make sure you guys realize that everything I've just done there, all that stuff, that is CV related. Just for the cardiovascular system, the chronic long-term adaptations from high altitude, potentially training, are absolutely significant, even magnificent. But we can go further. We have other types. Now I'm going to go green again, but the ones I go here for, the positives here, these are now no longer CV adaptations. We get an increased up arrow strength of respiratory muscles. I'll just put resp muscle, diaphragm, intercostal, sternocleidomastoid, scalenes. They become stronger. We get a positive because it's an up arrow of total lung capacity. Now, I want to be clear here, the lungs don't really get bigger. It's that we've got more muscular capacity around the lungs and we can reach the deeper lung better. As a result of this, we get an up arrow, an increase in tidal volume, the amount of air breathed in and out per breath. As a result of this, we get a decrease in resting breathing frequency, which we just call F. The number of breaths per minute goes down at rest. Therefore, a bit like our heart rate exercise range, we get an increase exercising frequency range. So we can go from fewer breaths per minute at rest to the same number of maximal breaths per minute, and that of course gives us a bigger range. And we get an increase in diffusion rate, as we've talked about already. So we actually diffuse gases faster. These factors here, which I'll go sort of around in some kind of purple or green or something, these are respiratory adaptations to altitude experiences. But we don't finish there. No, because we're going to go over here now, and we're now going to talk about metabolic adaptations. That says met for metabolic. What happens here? Well, we get better oxidization of fat. We're able to process fats better. This is called beta oxidation. And of course, if we can process fats better, it means that we can save glycogen for higher intensities. We get a decrease in insulin resistance, and as a result of that, more blood glucose can be carried into the cells for aerobic and anaerobic respiration. We also get positive, mentioned this one already, as a result of these things, we get delayed obla. Obla is delayed to a later point. We get an increase in both the size, that's a Z, and density of an organelle in the cells called the mitochondria. Remind yourselves, mitochondria are the site of aerobic respiration in each cell, and if they get bigger and more of them, as a result of that, we can do more aerobic work. We get more store of glycogen in the muscle and in I don't know what I've written there, glycogen. We get increased fat storage, which seems sort of a bit of an odd one. It sounds like we're getting heavier, but what that actually means is we're better able to access that fat storage efficiently. We get an increased percentage or proportion of SO fibers. These are slow oxidative muscle fibers. These are the ones that are aerobically sort of predominant. We get increased enzyme activity and we get decreased fat mass. These here are all, folks, metabolic adaptations. So those adaptations to altitude and altitude training are massive, and of course they particularly support an aerobic athlete. Think triathlete, think marathon runner, think middle distance runner. Particularly important. But we've also got some chronic impacts of being at low altitude if we do this. So here's one. First of all, this I'm going to sort of do this in sort of more of a neutral or blue, but we get fewer altitude effects. Okay, so if you're at sea level, of course you don't get all of those adaptations as readily. But even if you do, and then you go back to sea level, our effects wear off after 3 to 4 weeks. So if we go altitude training in Font-Romeu in the Pyrenees, Team GB, it's going to last for 3 to 4 weeks. Therefore, when would an Olympic athlete do altitude training? In the weeks running up to, for example, an Olympic Games. I'm recording this a few months out from Paris 2024. An example would be exactly that. Now, as a matter of interest, I've mentioned Font-Romeu in the Pyrenees. I'm actually going to a place on my holidays this summer called Auch, which is on the Spanish side of the border, and it's very close to Font-Romeu, and I'm going to be visiting. So there you go, folks. Cheers.